This is a video for AQA Further Pure Mathematics, Hyperbolic Functions, section 2.5, which is looking at further hyperbolic functions. Well, in a similar way to trigonometric functions producing new functions when we look at the reciprocals of them, so 1 over sine, 1 over cos and 1 over tan, then we can produce new functions by looking at the reciprocals of the hyperbolic functions. So for example, the first one here is 1 over cosh x. Now there are different pronunciations for this. Sech or shek are fairly standard ones, so you may come across different ways of pronouncing these. But shek x is 1 over cosh x. Coshec x is then 1 over shine, and coth 1 over than. So the reciprocals of the hyperbolic functions producing three new hyperbolic functions: shek, coshec and coth x. Let's now consider each of those in turn and see if we can work out what their graphs look like. Well, obviously we're just looking at the reciprocal, so here we've got the graph of cosh x, and if we think about its reciprocal, it goes through 1, so 1 divided by 1 is 1, so therefore this point must be on both of cosh and shek. The other thing that happens is that as x approaches infinity, cosh approaches infinity, therefore shek must approach 0. And you also notice it's always positive, so always above the x-axis. We can look at the domain. The domain is the values of x, and the range, the values of y that the function takes. So cosh x is true for all values of real numbers, and it takes its range. Cosh x is, as we can see from the graph, greater than or equal to 1. Shek is also true for all real numbers. It has a value for all reals, but we can see that it's got to be strictly greater than 0 and less than or equal to 1. Here we've got dotted the graph of shine x, and so if we look at that, it goes through 0, 0, it goes to the origin, and therefore as x approaches 0, 1 over that must approach infinity. So coshec x is approaching infinity as x approaches 0, and then shine approaching infinity as x approaches infinity means that coshec must be coming down to the axis, becoming closer and closer to 0, so it tends to 0. We can look at again at the domain and the range. Shine is true for all values of r, or is defined for all values in the real numbers, and we can see that shine x is also any value in real numbers for its range. For coshec, we can have all real numbers other than x being equal to 0, so it's asymptotic to the line x equal to 0, and it takes values which are greater than or equal to, greater than 0 or less than 0. So it is coshec x element of r not equal to 0. Here the dotted line is showing tanh x, and we can see for that we have x is a real value, but that tanh lies between -1 and 1, so we can say that -1 is less than tanh x is less than 1. That means that coth, which is 1 over that, is going to be asymptotic to the y-axis. It's approaching infinity, plus and minus infinity, as x approaches 0. And it's also asymptotic to the lines y equal to 1 and y equal to -1. So for cough we have that the range of values are equal to x values, I beg your pardon, the domain are all of the real numbers, but we can't have x equal to 0, and that the range, which is the y values, we have that coth x is either greater than 1 or coth x is less than -1. Well, let's look at some examples now using these new functions. So for example, we might be asked to evaluate sech of log 4. Well, the easiest way is actually to evaluate cosh first of all. So let's look at cosh of natural log 4. You can either do this directly on a calculator, so make sure that you can use your calculator to work out inverse hyperbolic functions and functions themselves, so that cosh of log 4 you should be able to see on a calculator is equal to 17/8. The alternative to that is to say that it's equal to 1/2, and then using the definition of cosine, so 1/2 e to the x, which is e to the log 4, plus e to the negative natural log 4. So 1/2 e to the x plus e to the minus x, and that is equal to 1/2. Well, e to log 4 is just equal to 4. Negative log 4 is the same as log of a quarter, so 1/4, and therefore this is e to that must be equal to 1/4. You can see there we've got 4 plus a quarter is 17/4, so therefore 1/2 of that is 17/8. So once you've got cosh of log 4, we can say therefore that sech of log 4 must be the reciprocal of that, so 1/17/8, which is 8/17. The other thing that we've done with hyperbolic functions is look at some identities. So for example, cosh squared x minus sine squared x is equal to 1. And from those also the other identities such as cosh 2x and sine 2x. These are familiar with the trig identities, but do remember that you need to be careful with the signs. They're not always exactly the same. But what we can do with these is now use the reciprocals to work out some new identities. So for example, if we divide through this by cosh squared x, then we get cosh squared x over cosh squared x is obviously 1, and then sine squared divided by cosh squared, that's equal to tanh x, so tanh squared x will be equivalent to 1/cosh squared x, which is the new function sech squared x. So that's just dividing through by cosh squared. And we could also do a similar thing, dividing through this time by sine squared x. We get cosh squared over sine squared. Well, that's 1/tanh, which is the new function that we've got, coth. So that's coth squared x. Sine squared divided by sine squared is 1, so coth squared x minus 1 must be the same as 1/sine squared, and that's cosec squared x. So these new identities produce in the same way as the trig identities produce new ones when we looked at dividing through them. And these identities can then be used to solve some equations which involve hyperbolic functions. So for example, here we've got an equation 8 sec squared x is equal to 7 minus 2 tan x. So we've got an identity now for sec squared, so we can replace that by the identity which says that sec squared is 1 minus tan squared x. So that must be equal to 7 minus 2 tan x. Rearranging that as a quadratic gives us 8, and tan squared x minus 2 tan x minus 1 is equal to 0. Now you can either think of this as being 8u squared minus 2u minus 1 if you like, or you should be able to see that this factorizes directly with the brackets having 2 in the first bracket, minus 1 and 4 tan x plus 1 in the second bracket. So therefore tan x equals 1/2, or it's equal to negative 1/4. Then using either your calculator again or the definitions of the inverse functions from your tables, then that produces x is equal to 0.549 for the first one, or x is equal to negative 0.255 for the second one. Well, that's the end of this video, and in the final one of this series we'll be looking at further differentiation and integration.